of technology we've developed called the Cruise Decision Engine here. And you see at the left, we've taken all the rich understanding from the world that Yoon talked about, that's in perception, and incorporated that into our decision-making process. The goals of that process are on the right, and the end goal is actually to produce a controls outcome. So this is braking or steering or accelerating, for example. So let's dive into what's inside these boxes. First and foremost is action generation. What we want to do is produce joint modes and distributions for all actors in the scene, actually including ourselves. This is called machine learning seeds. We're going to talk a little bit about this later and how we use it to accelerate our decision making. Once we've understood all of that, we're actually able to do a conflict resolution step. And in this conflict resolution step, we understand our actions, we make initial guesses at it, and then we revise that estimate of where everyone in the world is going, including ourselves. Now, we need to densely sample the scene because some trajectories that we are considering might go straight, some might bow out slightly, some might go to the left, and the goal is to pick the very best trajectory from a safety and comfort perspective. So once we do all of that, we can score those trajectories. This is where a lot of nuance lives inside of the scoring. This is a really hard problem to get right. I'm going to talk through a couple things that we do in scoring. The most obvious one is physics. Think of this as two vehicles can't operate the same space at the same time, otherwise that would be a collision, and other physics interactions. This is also where we incorporate some of the rules of the road, like how much distance we need to keep away from cyclists and pedestrians, for example, stopping at stop signs, etc. Next, we need to consider comfort, of course. Comfort is how smoothly we're driving around these objects given their uncertainty. And as I mentioned, we're always constantly hedging against an uncertain future. The future is never totally predictable. It might be highly predictable, but it's never totally predictable. In cases where we really just don't know how the world is evolving, we've actually developed a couple novel techniques to totally offline train systems using reinforcement learning to understand how to better make decisions when we don't have data or when the world is just evolving in an unpredictable way, which of course happens on the road. Last but not least, we have to consider our route options where we're going in the future as an important signal into costing. If we're trying to go right, we need to understand that we really want to bias our samples of where the AV should go to the right. Last, but certainly not least, is reflexive plan update. So this is where we actually take all of that and turn this into control actions. We incorporate the dynamics of the world and the dynamics of the vehicle. If you're interested in control theory or robotics, this is where a ton of that stuff lives, and we've amassed one of the world's best teams in this area to actually create the correct control actions using a variety of techniques from optimal control and robust control. If we do all of this correctly, which is a hard problem, with high frequency, we'll be able to generate the outcomes at the right, which is understanding uncertainty, kinematic uncertainty, existence uncertainty, 360-degree conflict resolution, understanding uncertainty from modeling errors, incorporating models of both the vehicle and the road into our decisions in order to drive safely and comfortably. So next I'm going to talk through a couple examples of how this plays out on the road.